So gotta get Alex's songs on record. Okay. And so every year in November, there is a big football game played between Stanford and Berkeley called the Big Game. And so the Stanford, oops, sorry, okay. That's that. Okay. And so the Stanford mascot is the tree, and the Berkeley mascot is the golden bear. And so every year around the time of this football game, you know, each school will do various things to the tree and the mascot. Okay. And so I thought I would just take a couple minutes, you know, we'll keep on showing up. Okay. I thought it would be kind of fun just to have you guys take a poll. Okay. You see the poll here. This is a little bit of NCAA football trivia as well as Stanford and Berkeley trivia. And so if you guys could just take your best guess, and then I will let you know what the answers are.
I like the Alex Vicky rivalry.
Do you guys see the poll?
Yep.
Yes.
Okay. So I think everybody has voted. I think like 6 people haven't voted. Alex, you should vote too. If you
I did.
okay. All right. So I'm gonna end the poll, okay, and then tell you guys the answers. Um, all right. So these are the actual answers, okay? So for the first question, what is the oldest NCAA college football rivalry in the United States? I actually got this one wrong. It's actually Yale Princeton. That one preceded Yale Harvard by 2 years, and then Stanford Berkeley is actually much later than that. And then of course, Alex and I, we have no rivalry, right? We're just like friends, okay? And then question 2, what is the prize trophy that's awarded to the winner between the Stanford Berkeley Big Game? So all of these are actual real awards except for B. B, Handsome Dan, is the actual mascot of Yale. It's actually a dog. But the golden egg is the trophy for Mississippi State versus University of Mississippi. A keg of nails is the trophy for Cincinnati versus Louisville. And the jeweled shalala is a Notre Dame trophy. And so the Stanford Berkeley trophy is the X. And then who holds the lead in the Stanford Berkeley Big Game rivalry? And so obviously it's got to be Stanford leading the series 66-51 with 11 ties. However, Cal has won the last 4 out of 5 matchups. And so there you go. And I think today I will probably lose my matchup with Alex, but that's okay. And then okay. So after next week on August 2nd, Alex will be back. It's like the return of Alex. And then we're gonna talk about files. And please know that there's a time change because I have a meeting I have to go to at noon, so I cannot host this at noon because I need to use the Zoom. And so we're going to move it a little bit earlier to 10 a.m. Pacific Standard Time. Hopefully that will be compatible with most people's schedule. And then I also have one other poll I wanted to get people's opinion on because okay. so one other poll. Oh, I can't launch this. Why can't I launch this poll? Okay. Okay, yeah. So basically, one of my daughters came home like 2 days ago, and then she told me that posting these videos on Google is like a very antiquated way of keeping them. And so she actually suggested that I post them to YouTube. Okay. So I just wanted to make sure people are okay with me posting onto YouTube, because if you post to YouTube, there is a certain loss of privacy, even though you can keep them there forever. And so if anyone is not okay with me posting it on YouTube, please let me know. I will not post onto YouTube unless there's like 100% consensus, because I don't want to like violate anyone's like privacy. Okay. And then Alex also wanted me to poll you guys. There is a very complicated example in the slides this week about a tic-tac-toe problem. So time permitting, how many of you would want him to go over that question? Okay. So these are the two questions. So it seems like not everybody is comfortable with me posting onto YouTube. And so even though the majority are, and so you don't have to say who those 4 people are, but since I don't have 100% consensus, I will not post it onto YouTube. So, okay. So that's it. Thanks for letting me have my moment in the sun, Alex. I am going to make you host, and I'll stop rambling now. How do I make you?
What was the answer to the first question? Do people want me to talk about tic-tac-toe or not?
What?
Tic-tac-toe. Do
Yes,
people?
it's an overwhelming yes.
Okay, all right. So we can then take a look at that
I don't know
one.
if we'll have time, but let's see. Okay, I've turned the host over to you, and yeah.
All right. So yeah. You're saying I have same question about recordings. I believe Vicky, I don't remember. Do you actually send links out to the with the recordings in your emails, or do we have them? Do we have them in the forum?
Yeah, so and so far I've been emailing the links onto a Google Drive. And so with the Google Drive, eventually I'm going to run out of space, and so I will have to delete those. And so my daughter suggested that I post them to YouTube so that it will be there forever, and then you can watch them wherever well, whenever you want, okay. But I wanted to make sure people are okay with it, because YouTube is much less private. And so unless we have consensus that everybody is okay with it, I don't think I will post them to YouTube. I'll just like keep on emailing out the links. But for the Google Drive, you need to download the files, because eventually I'm gonna have to delete the files because I just don't have space on my Google Drive.
Some people were suggesting creating a private YouTube account.
Mm, I mean, so I don't know how to do that. Like a private YouTube account. Okay, because basically there's only three options on YouTube. Either you make it private, or you make it unlisted, or you make it public. Okay. If I make it private and unlisted, I would have to still email you guys all the links. And then people who are not on the email list wouldn't know to actually go find those links. If I make it public, then anybody who has my YouTube channel could just go there and then watch the videos.
Okay, that makes sense.
So, I guess you guys can think about it and then we can take the poll again next week to see if people have changed their minds. You know, for
Okay.
me, it's not a big deal. I can just keep on posting them on Google.
All right, Blossom, you have a question?
Yeah. Oh, sorry, I'm looking at the second screen. I was just trying to type. I wasn't sure if I could type fast enough. I wanted to ask if, please, if you could add me to the email list because I've not been getting any of the
Yeah,
emails.
that's because you didn't give me your email. And so I don't have the email. If you type your email in the chat,
Okay.
yeah.
Thank you so much. I appreciate that.
Sure.
Thanks, Alex. And thank you.
Okay, so today we were planning to talk about
Thanks,
to-do
Vicky.
lists.
Sure.
And before we do that, Vicky sort of told me, because I'm not in the Discord group in which some of you are, and she sort of pointed my attention to the facts that some of you were asking whether you can actually ask questions during our sessions, much like, for instance, Vicky or Nate asked at some point, and the answer is a resounding yes. If you feel more comfortable asking questions via voice and via your microphone, please do. There is no like strict code of behavior here. Like everyone types their questions and only Vicky is allowed to ask them by voice. If you want to ask them, please do it at any time. You can, interrupt me if you need something explained from some previous concept. So don't feel any pressure to write that in the chat or stay quiet about it. Please do ask. I'll answer any questions that you have in the moment. So 2D lists. If we talk about 2D lists, let's have a very quick overview. Let me open PyCharm so that I have somewhere to type my code, and let me share my screen. Just give me a second. New Scratch file. Yeah, that works for me. So I'm trying to share my screen now. Do you see my screen?
Yes.
Okay, nice. And let me make the font size a bit larger. Let's go for 32. So basically, we know what lists are. For instance, this is a list, right? This is a list of integers. This is a list of names. I don't know, Nika, Blossom, Nate, whoever. I'm not going to list out everyone. You can have a list with different types of data, like 3, whatever. So what's a list of lists? The idea is that lists are collections or like sequences of values, and those values can be of different data types. So the question becomes, can a list be, can the elements of a list be lists themselves? And of course the answer is yes. So for instance, if I do this, then I would get a list of lists. If I print this LST, you would see that it's a list that contains other lists. Yeah, this is the first one, this is the second one, this is the third one. And if I want to access one of these elements, I would do it the same way I would do it with a regular list. So for instance, if I want to access the second list, I would use index 1, because the first list is index 0, the second one is index 1, and I sort of get that one. So then the question becomes, how what do I do if I want to access one of these specific values inside that list, which is inside another list? For instance, if I wanted to access Mika's name, I would just have to add another index here, because this is obviously, this is A, because here, not A, but B. So if I wanted to get the second index of B, I would have to write it like this. But since instead of B, I could write LST1, so this would give me Mika. So this is the reason why the syntax for accessing specific values within a list, which is part of another list, why the syntax looks like this. And we had a bunch.
Alex, I have a question. So how does the, oh, no, I got it. Sorry. I was going to
Yeah.
ask you how A, B, C is read as lists rather than just the letters A, B, and C, but then it's in different brackets. So that's
All
what I-
right, because if it were like this, then it would be the letters. But since I don't have the quotes, so obviously this would print ABC, and then this would not work because there are no indices there. So we had a bunch of assignments put together for us by Vicky. Thank you, Vicky. And here is the list. So my question is, we decided that yes, we want to look at tic-tac-toe, which was in the lectures. Yes, we want to take a look at sandcastles, which is difficult. My question is, are there any other assignments which you had issues with? Or maybe you didn't understand the solutions, maybe you had questions. Let me know. I'd be more than happy to take a look at other specific assignments before tackling tic-tac-toe and sandcastles, which are sort of a bit more complex, I would say. And let me quickly look in the chat because I'm not.
I had problems with the firecracker one, but okay, I wouldn't prioritize that over the other two. I can just ask you via forum as well. Because I think a
Sure.
lot of the concepts is like embedded into sand and tic-tac-toe. So
Okay, got it. I mean, but if someone else says that they want to look at fireworks, we could do that. Nate, I see you're saying how are lists with multiple dimensions represented in Python? I'm not very knowledgeable in algebra or machine learning, but multiple dimensions. I mean, this is one of the ways to represent multiple dimensions. This is a two-dimensional list. If you want a three-dimensional list, you could also have a list which has lists as its elements, and these lists also contain lists. So for instance, if I were to do something like, I don't know, 1, 1, 1. This is like 2, 2, 2, or 2, 2, 3. It doesn't matter. So this then would become a three-dimensional list, and this could be used, for instance, in 3D graphics to represent voxels, which are the 3D analog of pixels. Pixels are 2D, voxels are 3D. So here you would have, this is the first list. Inside this first list, you would have, for instance, D as the second list. So this is the second list. And inside D, you would actually have three more, which are the third dimension of the list. And there are no limits how many dimensions you could have. So you could have like 2D matrices, you could have 3D. I'm not sure whether they're called matrices or not when they're 3D. Like I said, I'm not a math major, so I'm not too good with those things. But this is the way you represent them. And if you have like a 3D list, you would, for instance, have another index here and access your list with 3 indices instead of 2. So I'm not sure whether that.
Alex, I was just, I don't think there's a point to stick on at all, but ultimately where I want to go with this is to learn how to do machine learning. And there can be vectors with very large numbers of lists. And I was just kind of curious how it might be represented within Python, but I'm guessing there might be libraries to deal with those kind of things, because it could get very unwieldy, visually, the way we do Python to try to represent things that long, I think.
I'm sure that there are libraries which actually have vectors as data types. They are not basic data types or what you call primitive data types. So they are actual classes and you would create objects of those classes. But I am certain that there are vectors as a special data type which you could use. Once again, I'm not that familiar with the specifics. I'm good with basic math, but anything, over the top of high school algebra is beyond my understanding. So yeah, talking to me would be like talking to a watermelon in that sense. Yeah, also I see the question, Abhinav, I see your question about unit tests and how to write tests. Well, today we're gonna talk about doc tests because in the Sandcastle problem, we have doc tests, and I'll gladly talk about what they are and how to use them. So we will come to that. Are we going to cover object-oriented programming in the future? I mean, I don't mind. I know one of the topics is classes and objects, etc. I'm more than happy to talk about object-oriented programming. It's not a simple topic, but I'm willing to tackle it. Okay, so I'm done, I think, with the chat for now. So hold on, I saw a couple of assignment names. Give me a second. Rotate list and Sparks were annoying. Well, let's take a look. Let's take a look at them.
Hi, Alex. It was me who said that, but given that send is long and demanding, I think it's okay to skip that.
Yeah, we could do that. I mean, are you in the forum? Yes, of course you are.
Yours?
Yes.
Yours? Yes, I am.
Yeah, you are. So if you have a specific question about a specific assignment, feel free to drop me. You can do it a private message through the forum, and I'll be happy to answer it.
Thank you.
Vicky does it all the time. So I'm always answering Vicky's questions. So if you have questions, please do ask.
But Vicky is Vicky. She has her privilege.
Vicky is certainly Vicky, but that doesn't mean that she has, priority. Well, maybe she does a little bit, but that I will not answer other questions. I am more than happy to answer any questions that you might have. So please do to send them through the.
I will also say that Rotate has a solution, and so you can look at that solution. I think the solution was helpful. I think Firework or Spark doesn't have a solution. So.
So Fireworks and Spark is the same one.
Oh, wait. I think Firework might also have a solution, but the solution made less sense to me. I may be misremembering anyways, so.
Let me take a look. Rotate. Okay, here's Firework.
I'm pretty sure Rotate has a solution.
Probably does. They probably all have them. No. I mean, we can take a look at Fireworks if you want. Shall we? Can you run line 8? What do you mean by line 8? Man, can you let me know what you mean by running line 8?
You won't watch. You turn light on, okay?
How to what?
I don't know whether you want to sit down.
Yeah.
If that means I'll just go along.
Does someone have their mic on when you do not want to have your mic on? Because I don't think you're speaking to me. Aria. I mean, right now it would give an error because, yeah, I added this, but at the moment, if I print, it will print Mika because LST1 is A. No, sorry, it's B. And if we take a look at B and we take index 2, Mika is at index 2 in this specific list. So it will print out that specific value, which is stored there. So yeah, one more time, I'm not sure how to get the answer, whether we want to look at fireworks or not, so let's just do it. So list of list 2D grids, 2 dimensions, so we have a grid like this. So let's scene with certain physical properties. Either a firework or a sparkle represented by S or none. We want to loop around to the F to none, putting sparkle to the left, right bottom. Let me, I'm just having a quick read, refreshing it in my mind. Okay, no sparkles will overlap, but then the firework can be placed at the edge of the grid. So we do not want to try place something there because we will get the out of bounds error. So for instance, here it's obvious. Okay, so let me, for instance, let me take this example. Maybe I will add something to it. So here is, what's it called, grid. Grid equals, let me just make it a bit nicer looking, like this. So we have a grid, and we have 1, 2, 3 fireworks, which are all located at the edge of our field. So we need to define a function. Let's say it's called explode. What's the explode fireworks? Okay, explode fireworks, and we get the grid as the parameter. I'll put it a bit later, somewhere here. Yes. And we will call this function. We could save it back into the grid, but that's not really necessary because this is the list. So we'll be changing this list, and let's print the result after that to see how it changes. So the idea is that we will go through all the rows. I will go like for row. Do we need the indices? I guess we would need the indices. Let's say for y in range len grid. So the length of the grid would be the number of sublists that they have. In our case, we have 1, 2, 3, 4. So the length of the grid would be 4. The range would give me 0, 1, 2, 3. Those are the indices. This is index 0, this is index 1, index 2, index 3. And then inside, I would go for x in range len grid, let's say 0, because the grid is a matrix, so it has the same number of values in each sublist. So I can just take, like, the first one, take its length, and it's going to be 5. 1, 2, 3, 4, 5. So the range would be from 0 to 4, which are the indices 0, 1, 2, 3, 4. So now inside, I would have to check whether whatever is located at yx at the moment is a firework. Because if it's not a firework, nothing is going to explode, nothing is going to happen. But if it is a firework, I would need to do 5 things. The first thing I need to do is I would need to change whatever's located at that location to none because the fireworks exploded. It's no longer there. Then I would have to place something above it, below it, to the left to it, and to the right of it, but only if there is space. So only if it's not on a specific edge. So let's go with, north, up, whatever you call it. So in order for me to check that there is a space above, I would have to check the y coordinate. And I would only say if y is greater than 0. In this case, I would go to y minus 1x and set it to the spark. And guys and girls, please let me know if anything that I'm explaining, you have questions, just shoot them right away. And I would actually prefer to hear them by voice because I see now there are 7 messages in the chat and I'm sort of like, I'm not seeing them. Let me see quickly. I'm just afraid I'm going to miss some of your questions. And I don't even know where they are. I think there are some sub discussions which I'm missing. So if you have a question, please do tell me via voice, because otherwise I'm going to spend a lot of time looking for the questions in the chat. So let's go now with the down. So in order for me to place something below the exploding firework, I need to make sure that this is not the last line. So which line is the last one? In our case, it's 0, 1, 2, 3. So the last index is 3, and the length of grid is 4. So I would say if y is less than len grid minus 1, because like the length is 4, the last index is 3, and only if the index is less than 3, so it's here, here, or here, would I want to change something which is placed below, so at y plus 1x. And we would then do the same for left and right. So for
Alex?
left, yeah.
Sorry. Okay, can you explain again, like, how did you get the grid y minus 1 and the grid y plus 1?
Sure. So basically, for instance, let's say we're going through the first line of the grid.
Yeah.
What is the y for this line?
It's y. No. Sorry, it's 0.
It's 0, exactly. So what's the y for the next line?
That's 0 plus 1, so that's 1.
This is going to be 1, and if there were a line above, that would have been minus 1, but whatever. For instance, if this is 1, the one above is 0, the one below is 2, correct?
Right.
Okay, so this is why I'm using y minus 1 here. So I'm saying go to the previous line in our 2D list to the same x, but the y is minus 1. So
Okay, and so that's one line above.
Yes.
Okay.
And y plus
and
1 is one
below.
line below. Exactly.
Okay. But where I got tripped up is, what if you're like at the topmost line or the bottommost line, right? If you just write this statement, it doesn't really check for the boundary conditions, because if you're at the topmost line, there's no line above.
Right, that's why I'm writing these conditions. So the first condition says, if your line is more than 0, that means it's not the top line, only then place something above, because if the first line there is nowhere to place, you'll get an error. And actually you won't even get an error, you would get a placement at a completely different location, because you would have the index minus 1, and the index minus 1 is actually the last line. So that would screw you over. But this one will kill you. This one will lead to an error, because you would try to access index 4 and there is no index 4, and you'll get an index out of bounds error. And you would do the same for left and right and for x. So you say if x is more than 0, so it's not the leftmost column, you would then do grid y and x minus 1 equals to s. And the same logic applies to the right side. If x is And here is the important difference. Here I write grid 0. So I'm taking the length of one specific row. In our case, it's 5. And if it's the index, if it's smaller than 4, because the last one is 4, so we're only looking at indices which is 0, 1, 2, or 3. In this case, I would go to x plus 1 and add an s there. And I think this should work, but maybe I'm not, I'm not sure whether I took everything into account. Let's see. Let's print the grid before the explosion and then right after the explosion to compare them. This is not the best way to look at them, so let me do it a bit more nicely. Let me print it like this. And let me do the same thing here. Let's separate them. So here, the first one, we see the F, it exploded here, here, and here. It did not go up. This one exploded here, 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 did not go to the right. And this one exploded here, here, and here. It did not go down. So at first glance, it seems that it's doing what it's supposed to be doing. Maybe someone will tell me, Alex, you forgot about something. But so far, it looks like it's working. So give me a shout out if you understand the logic behind this code, like Vicky and Leah, you had the question, or is everything clear? Okay, Vicky.
Clear, but
up.
I have one question at the bottom of the code.
Yeah.
You can go. What is this star grid operand?
Okay.
At the print line.
Right. The operand is actually the asterisk itself. Grid is the name of our list. So what the asterisk operator does, it actually takes a sequence and it breaks that sequence into its parts. So instead of printing the entire list of lists, it takes each of the elements and sort of passes them here separated by commas. So remember, when you type something into print separated by commas, you can then tell Python what to place between those arguments. So by default, it places spaces, but I told it to place new lines. So what it does, it actually takes the first element, then does the next line. It takes the second element, it does the same, takes the third element, and so on and so forth. Basically what this does is open up the sequence into its constituent parts. So now instead of one list, you have 4 sublists sort of separated by commas. Does that make sense?
Yes, it's the same as you did in the breakout, but you were using tuples, right?
I
like that.
I frankly don't remember. That might be the case. The same would work with tuples. So for instance, if you would have a tuple, this operator would open up the tuple and split it into all the values inside that tuple. Yeah, so you can use this operand with anything that has multiple values, like tuples, dictionaries, lists, what have you.
Got it. Thank you, Alex.
Okay, no problem. So then I guess we're done with this one. Do you need this code, or do you want me to save this code and post it in the forum, or is it more or less clear?
Yes. Yes.
Okay, let me then open a new file so I don't lose this one. Okay.
Yes, please save it.
No problem, Jay. Yeah, I'll do that.
Thanks.
So the next thing we wanted to discuss is the tic-tac-toe code, because frankly, I discussed it with Vicky and it's not that simple, and there are some things there which are not well explained. So let me, spend some time with you. Vicky, can you remind me which lecture do I have to open to get to that?
Second one.
Which one?
Second one.
The second one. Okay, give me a second. Okay. Yes, please. No problem. So this is review, swapping elements. Yeah, there was a question, an interesting question in the forum. I don't remember right now who asked this question, but the question was, do we really need a temporary variable in order to swap elements in a grid? And the question is, no, we don't. We do not have to do it like this. But the idea, I think David thought probably that the idea for this is that you would have to use this algorithm if you're using a different programming language like C or C++ or maybe even Java, which do not have some of the syntax that Python has. Because in reality, in Python, you can do this in one line. You would write something like grid row 1 call 1, comma, grid row 2 call 2 equals grid row 2 call 2, comma, grid row 1 call 1. And that would actually switch the values of the two elements. Yeah, Mick, I remember it was you. So to give you a very short example, for instance, let's say we have A equals to 5. It doesn't matter, or to 6. It doesn't matter what the data types are. B equals to, 13. And we want to switch those two variables. So in other languages, you would have to do temp equals A equals B equals temp. And then when you print A and B, you will see that now they're not 6 and 13, but they're rather 13 and 6. So we switch them places. But this is the long way, because the short way, let's now switch them back, is to actually write this. And Python understands this perfectly. It takes the value of B and places it into A. It takes the value of A, places it into B. So if we run this file, we see that they're back at 613. So I would use this, obviously, not this. This is too long to verbose, and it requires an extra variable. But I think, once again, this was done to make it clear how the algorithm would work generically. So now let's go back funky with lists. No, we don't want to get funky. We want to get burritos. Okay, here we go. Tic-tac-toe. I'm thinking what would be a better way to go through this? I could just go through the slides and sort of comment them, and if you at any point in time have a question about a specific line or a specific function, just give me a shout out and I will answer the question. So this is the main program. So the main program takes up less than 20 lines because we are going to use subfunctions. And the first line here creates a constant. The constant is size, and a typical...
Alex, sorry, can I make a suggestion? Can you actually share the slides so that people can...
Oh, you're not seeing the slides right now?
Yeah. It would probably be easier if people see the slides.
I did not know that you're not seeing the slides. Yeah, please tell me, because I thought I was sharing the slides and I'm not.
Thanks.
Let me do this one more time. Do you see the slides now?
All good.
Yes.
Okay. Guys, if you do not see slides and I'm explaining them, please tell me, because I'm not the kind of person who is not showing slides and wants you to, sort of visualize them. It just means that I think that I'm showing them, but I'm not. So yeah, one more time. Here we have...
Do that stupid ass piece of shit.
What? I'm sorry. I hope you're not talking to me and you're talking to someone else.
Oh, sorry, I was on mute. I had a problem.
So we have a constant size, which is usually 3, because a typical tic-tac-toe board is 3 by 3. But this program is scalable in the sense that if you input another size, you could actually play on a 4 by 4 board or a 5 by 5 board or you know, 100 by 100 board, and it would still work. It wouldn't be a very fun game, I would presume, but you could do it. And then we're defining the main function, so at the end we're just going to call this function. So here we will have a variable called winner, which initially will be none because we don't have a winner. But at the end of the game, it would either be X or O if that player wins, or it would remain none if no player wins. So then we're going to create a board. And for this, we would have a separate function which would create and return an empty board of a given size. So let's take a look at that specific function. The function would look like this. Here n is the size, so it's the same. The parameter is just called n. We will first create an empty list. And in the end, of course, we'll create a list of lists. So we would go in a nested for loop. So the first one, we would go 0, 1, 2. So we'd have 3 repetitions here if size is 3. And we would create a row, an empty row. And then we would go into another loop. And since it's also size 3, so we'll repeat this 3 times, we will add the value none to this row. So at the end of this loop, we would have a list which has 3 nones. So none, comma, none, comma, none. And that would signify a single row of our game board. And here, after this loop is done, we would add it to the grid. So now our grid has 1 row. And then we would get another iteration of this loop. We would create another row. For this another row, we would add 3 more nones, and we would add the second row to the grid. And then the third time, the charm, we would do the same. So at the end of this function, we would have a grid, a 2D list, which consists of 3 rows, and each of those rows consists of 3 non-values. So it would be a square of none, 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 none. It's like 9 nones. It's a very interesting image. And at the end, of course, we return this grid. So now we know what we have stored in our board variable. So next we set player to be X because obviously X always starts the game. And we will have a variable which sort of counts the number of moves that have been made. So at the beginning of the game, it's 0. And the maximum number of moves that you can have is 9. So after 9 moves are done, the game is over if no one has won because there is nowhere else to place. So after this, we will have the main loop of the game. So this is the entire loop where turns are taken, the board is updated, we check whether there is a winner or not, etc., etc. And the condition for this loop is while winner equals none. That means that until we have a winner, we will go through this loop iteration by iteration by iteration. As soon as we get a winner, this loop will stop and we will get here and print the final board and say this person won or no one won, depending on the result of the game. So inside, what we're going to do inside, we will first print the board, and we will have a separate function for printing a board We'll talk about this later. But first, I want to go like through the entire logic of this loop. We first print a board, then we ask a person to make a valid move. And here we will check and make sure that the move is valid. After we do this, we increase the number of moves by 1, which is logical. The player made a valid move. Next, we will check whether the current player actually won the game. So we're going to check whether he's a winner or not. And if there is no winner, then we will check whether all of the spaces have been filled. How do we do that? If, for instance, we have size 3, then 3 squared is 9. So when the number of moves is 9, that means that the game is over, no one has won, and we make winner no one. For instance, if we were playing on a 4x4 board, this would be 16. So as soon as all 16 cells on the board are filled, we declare that no one won and end this cycle and reach the end of the game. Otherwise, if this doesn't happen, we flip the turn. So we basically make the next player the current player. And this is what the main program looks like. Now let's take a look at the details of like specific functions. So how do we print the board? In order to print the board, we need to know how many rows we have and how many columns we have. And this is similar to what we've done with fireworks. So the number of rows is the length of the board, and the number of columns is the length of any single row in that board, but we'll take the first row, yes, at index 0. So now we know the number of columns and the number of rows. And it's actually, it's sort of strange why would we need rows and columns here, because it's the same number. We have a square game board. But I mean, why not? So then we launch a for loop, and inside this for loop, we start another for loop. So the first one goes row by row. The second one goes column by column in one specific row. And remember that our board is a collection of 9 values. At the beginning, they're all none. And we take a look at the specific cell. So this is going to be 0, 1, 2. This is also going to be 0, 1, 2. And those are the indices of the board that we have. So for instance, the leftmost topmost cell has indices 0, 0. The last one, like the bottom rightmost, has 2, 2. And we take a look at the symbol which is located in our 2D list at that specific index. And it's very important to remember here that Y represents the rows and X represents the columns. And here is a condition which is not very easy to understand if you are not aware of how this would work, because it's not very clear what does it mean if not symbol. And the thing you have to understand here is that whatever the symbol is, there are 3 options. We could have none, we could have the string X, or we could have the string O. And you have to understand that in many programming languages and Python as well, any value of any data type that you have will evaluate to either true or false if you place it in a condition. And the rule is the following. For any data type, you usually have only one value which is evaluated to false. So for instance, with integers, 0 is evaluated to false, all the other integers are evaluated to true. With strings, an empty string evaluates to false, all other strings evaluate to true. With lists, an empty list is false, all other lists are true. For dictionaries, it's the same, an empty dictionary is false, an empty tuple is false, etc., etc., etc. And in our case, we have none, we have X, a string, and we have O, a string. And the thing is that none, which is a special value of none type, there is a data type which is called in Python none type. It has only a single value, which is none. It's not a string, it's a special keyword, much like true and false. None always evaluates to false. So what this does, it says if the symbol in the board at the moment is none, symbol evaluates to false, not symbol evaluates to true. So if you have none here, this condition becomes true and the symbol is changed from none to an empty space. And this is important because we're not going to be printing none, we're going to be printing empty spaces. And after that, we print whatever the symbol is. If it's an X or an O, we print an X or an O. If it was none, we print a space because now the symbol is space. It's still none in the board. We have not changed the symbol in the board, but for this specific function, we changed it to a space, so space is printed. So now we have the symbol. After that, we have a condition which says if X is less than size minus 1, and you sort of go, what does that even mean? Let's remember, in our case, for instance, size is 3, size minus 1 is 2. So it says if X is less than 2. So if X is 0, this condition is true. If X is 1, this condition is true. If X is 2, this condition is false. What this does, it actually prints this vertical line between the first and the second symbol and the second and the third symbol, but it does not print it after this third symbol. So this is the line which separates, the horizontal and the vertical lines, which are used to separate like X's and O's on the game board. So this is the game board itself. So we place one, we place the second one. Else we just go to the next line because we need to start drawing the next line. It's not necessary to place these quotes here. You can just print open parentheses, close parentheses. This is redundant. You can do it, but I don't know why, they're doing it in this presentation. And when this entire loop is done, you've drawn one row of your board. So you have, in the first iteration, you draw the first row. In the second iteration, you draw the second row. In the third one, you draw the last row. The only thing we also need to do, if we need to draw a horizontal line between the rows. So while your Y, remember Y is the row, while your Y is less than 2, so when it's 0 or when it's 1, we will print a row separator. And this is a separate function that will draw a separator, a row separator. And we can actually take a look at this function. It's a very short function. Here's what it does. It prints sort of the first part of the separator. Then it goes in a loop for from 1 until the number of columns minus 1. So in our case, for instance, we have 3 columns. So we go from 1 to 2, which is like once. Let me try to figure it. Yes, this is going to be done only once in a 3x3 board. If we had a 4x4 board, this would have been done twice. So this line here draws this part. This loop here draws this part, and it does it only once. If it were 4x4, we would have another one like this and another one like this. And then at the end, you draw this. So this is like the end of the row separator. And we would have this row separator after the first row and after the second row. And this is what it would actually look like. Yeah, so we print the symbol, we print the vertical line after 0. Here we print the space because this is none. We print another vertical line because after 1, then we print the third symbol and we go to the next line. We do the separator, then we print the second row, we print the second separator, and then we print the third row. And remember, there is no separator after the final row, because then otherwise it would look ugly. So now we
Alex?
have, yeah.
Sorry, can I ask two questions? So when it prints the board, okay, it's not really going to have those X zeros in place of the board. It's just gonna print like an empty board, right?
At the beginning of the game, yes.
Right. And so I think the output of the print board initially is going to look a little bit different than what's shown here. It's all going to be blank. There's not going to be any
Sure.
X and O's,
Here it's
right?
shown for this specific
Grid.
yeah, for this specific grid.
Yeah. So my second question is, in terms of that if not symbol statement, okay, instead of using that if not symbol statement, why don't they just set everything to be empty in the beginning instead of like setting it to be none and then using this if not symbol? Because like, couldn't you just start with like an empty board with like spaces and then as you place like X and Y, X and O's, okay, flip that empty space into an X and an O rather than
Sure.
using this if not symbol?
Sure. I mean, that would have been the way. If I were to do it, I would actually place spaces inside this board instead of nones. I do not remember. I remember we discussed this, and there was one place where I thought, okay, now I understand why they're using none, but I do not remember it at the moment. Maybe we'll come to it later. So let's keep this question in mind, but it's certainly feasible to use spaces instead of none. That's the way I would have done it. It sort of saves a bit of hassle. You would not need this line at all. You would be able to immediately work with it. You said you had a couple of questions. Okay, the first one was about the board. Okay.
Yeah, that's all my questions. Thanks.
Okay, so let's go back. So now we have the printed board. So the next function we need to look at is actually player turn. So getting a player's move, and notice that this function does not return anything because the result is not saved anywhere, because we're going to do all the saving inside the function. So the idea behind this function is that it should force the person to make a valid move. As long as the person keeps moving and making invalid moves, it will not allow the game to move forward. So here's the way it works. The function gets the board and the symbol of the current player as parameters. And first we will create a function which is called valid move and set it to false. What this means is that at the beginning of the function, we're sort of like, the player has not given us any move yet. The absence of a move is not a valid move. So we will, sort of, for now, we do not have a valid move. And this is important because we will have this variable as the condition for the while loop. So it says, while there is no valid move, so as long as this is false, we will do this. As soon as it becomes true, the function will end. So what do we do inside? We print the first line, a blank line, okay. Then we say it's either X's move or O's move. This is printed here. Then we will ask the person to input the row and input the column, the number of the row and the number of the column. And here we have to be careful because it's actually not the number, but the index. So you'd actually have to print 0, 1, or 2 instead 1 or 2 or 3, because otherwise you would go overboard outside the indices. So I would actually, if I were to write this game, I would actually change this into numbers and then subtract 1 from the result. But let's look at it the way it is right now. And after we get the row and the column, we have to make sure that this move is valid. What makes a valid move? There are two things that we need to keep in mind. The first thing is that the number or the index of the row and the index of the column are inside the board. So only zeros, ones, and twos are legal for a board of size 3. So how do we check this? We say that if row is less than 0, or column is less than 0, or row is greater or equal to size, because if we have size 3, we cannot have an index of 3, we can only have 0, 1, 2, or if column is greater or equal to size, then this would be one of the reasons why we would call it an invalid move and say, you know, try again. But then there is this sort of strange looking condition. And this is the condition, Vicky, this is the reason why they're actually using none. Although, you know, this could have been done differently. But yeah. The thing is that we also need to make sure that there is nothing at that cell, because we cannot replace one symbol with another symbol. If there is already an X there, we cannot place an O there because that's an invalid move. Try again. So what this condition does, it actually checks the symbol at this location. And once again, if there is already an X or an O there, this would evaluate to true for the same reason I explained previously. If there is a none at this location, it would evaluate to false. And if this evaluates to false, if all of these conditions evaluate to false, then the entire condition is false and it's not an invalid move. In this case, it will become a valid move because we will go to the else clause of this condition. But of course, like Vicky proposed, let's not use none, let's use a space. And we could have written here, or board row column does not equal space. This would have given us the same result, and frankly, I think that would have been more readable for another person reading the code than this sort of obscure and, you know, sort of mystical condition where you go like, what does this even mean? This is not even a condition, you would sort of go, there is no condition here, but there actually is, because any value evaluates to either true or false. So
Alex, suppose the player were to input none, would that make it true? And then
no.
That would
the reason is that when you input none, it would be read as a string, and the word none as a string is not the same as this special value. Similarly to how true and false, if you type them as a string, are not the same as true or false, the Boolean data types. Moreover, I would tell you, in these two lines, you would actually get an error if you try to type anything in here which is not an integer. There is no error protection here, which is bad. You do need to have error protection here to make sure that a person enters a digit and not something else, because as soon as a person enters, you know, a letter here or a word here or a space here, or just presses enter without anything, the program is going to crash. So this specific program believes that the user, you know, will be handling this input correctly, and the user will input integers, because anything else will break the program. Does that answer your question, Mika?
Yeah, I forgot about the integer input before. Thanks.
Yeah.
Alex, sorry, one other question. So for the while loop, okay, just a more broad general question. The while loop here, okay, it's basically while not false, okay, it will execute that block, correct?
Right.
Okay, and so my question is, okay, sometimes I have a very hard time realizing, like, okay, when do you need to use like a while true loop? versus something like this, okay? I'm not even sure this while not false loop. Is there any difference logically than if I were to use a while true loop?
Sure, there is a very important difference in that you can actually affect this loop, but you cannot affect the while true loop. For the
Got it.
simple reason that if you have while true,
It's
you will
always true.
never be able to change that true. And you would need to have to use a break statement to break out of that loop. And using break statements is somewhat frowned upon unless you actually have a very good reason to do that. So in this case, that would not be a good reason.
Got it.
While in our specific case, we can actually, using else, change the value to true, and that would terminate the loop.
Okay, and so when you think about these while loops, okay, how do you know if you want to start the condition with a true condition and then execute and then have the else be false, or start with like a while false condition and then have the else statement execute when it's true?
You cannot start with a while false condition.
Really?
Your condition, because if it's while false, the loop will never execute.
Well, because like, couldn't you write something? I mean, well, couldn't you write something like while valid move and then execute? In which case that would be a while false loop.
Then the loop would not execute.
Oh, really?
Sure. It's like, imagine it's the same if it were an if, because a while loop is the same as an if, with the only difference that an if works once and a while loop works until the condition is false. So if you were to write if valid move, would that condition work?
That's like if false.
Yes. Would if false work?
I mean, okay, logically, I would have thought it could work because the computer doesn't care about which Boolean condition you're giving it. I mean, it just cares about if it's true or false. And then I
But
thought,
false is false, that's the problem.
well, I could play around with it, but intuitively, I would have thought it would have worked.
No, I mean, in the end, the only rule for conditions is if it's true, it works. If it's false, it doesn't work. You could have written something like, I mean, instead of writing while not valid move, you could write while valid move equals false. And that is the same thing sort of said differently.
Right. I mean, if you were to write that as your starting condition, you could get the loop to execute, right?
Right, but the reason for that would be that the condition would still be true. The statement that valid move equals false is a true statement. So that's why the loop would launch.
Okay. And so in summary, okay, for any loop to launch, that condition in the loop has to be evaluate to true. If it evaluates to false, the loop would just exit. Okay.
Yes.
And then the difference between a not false loop versus a true loop is that the not false you could potentially toggle and change, whereas a while true loop, it's just always kind of true.
No, a not false loop is also always true. It actually has to be something here that you would be able to change.
Right. Yeah.
A variable, a changeable variable.
Yes, understood. Thank you.
Okay, cool. So yeah, going back to else. So if any of this condition, if a single condition here is true, that means it's an invalid move. We try again, we go back to the beginning of the loop, and we ask the person again to input his move. However, if all of these conditions are false, so none of the rules are broken, then we go into else, we add the symbol to the board at those specific indices, and then we change valid move to true, because now we have a valid move. This terminates the loop, and this terminates the entire function. So the function ends. You may have a question like, Alex, why doesn't the function return anything? Shouldn't it like return the result of its work? And the answer is no, because since grid is a list and the lists are mutable, any changes that are done to a list inside the function persist outside the function. So you could, we could have returned the grid. We could have actually written here grid equals player turn board player, put return grid here, and the result would have been the same. But why type extra code when you don't need to type extra code? So yeah, this is the way this function works. The next function then we need to look at is check winner. So after a person does a move, we need to check whether there is a winner, because if there is no sense in continuing the game. A person won. How do we check a winner? If we were playing if we knew that each and every time we would play on a regular 3x3 board, this function would have been a lot simpler. But since we do not know the size, it could be 4x4, could be 5x5, could be 100x100. We need to go into some crazy stuff. In any tic-tac-toe game, you have basically 3 ways to win. You could win vertically, you can win horizontally, and there are 2 diagonals on which you could win. So we will check those 3 conditions. The first one, we will go through rows. So we will check row numbers like 0, 1, 2, and there will be a separate function which is called check row. We will check whether all of the symbols on the game board at that row are the same. And this function will return its result to the winner. So let's take a look at that function to understand how it works. So here is that function. We get a row, so we have the board, we have the row number. So we sort of go to the first symbol in that row. So let's say we're looking at the first row. And for instance, let's say it says XXX. So that's supposed to be a win, right? So we'll look at the first symbol and we see that the first symbol is an X. So we remember the first symbol is an X. And then we go across the remaining indices. So we'll look at the first index and then we'll look at the second index because size is 3. So this would return 1 and 2. And we check if the symbols at the next cell match or do not match the symbol that we found. So we have X here and we look like, is the second one an X? And if the statement, if it's not equal, so let's say it's just an empty space, then we can immediately return none. So there is no winner. There is no winner on that row. However, if we check all of the cells and in each and every cell, the symbol is the same as the original one, we know we have a winner and we return that specific symbol as the winner. So at the end of this function, let me go below. At the end of this function, we either have none here if there is no winner, if there is no 3 in a row, or we return X or O if we found 3 X's or we found 3 O's. And here where it says if winner, it means if it's an X or if it's an O, because remember, if none is going to be false. If none is false, we do not do this. However, if we have an X or an O, we actually return the winner. We say like X is the winner or O is the winner. Then we have a similar thing for columns. So we check all the columns, we go, column by column, and we have a separate function which checks columns, which is very similar. We just change the indices here. In the previous one, we had row 0, and here we have 0 column. The idea is the same. We take the first symbol in a column, then we compare it to all the other symbols in a loop. And if at least one of them does not match, we return none. Otherwise, we return the winning symbol. So it's the same logic, but vertically. And finally, we have the diagonal. Inside the diagonal, we actually have, if I remember correctly, we actually have two functions. We have the down diagonal, we have the up diagonal. Just kill me, but that's the way it is. So for the down diagonal, the down diagonal has the same x and y values. So we need to check 0, 0, 1, 1, 2, 2, 3, 3, however large the size of the board is. So here we start with the first symbol, which is at indices 0, 0. Then we check the remaining ones, which is like here, 1, 1, and 2, 2. And the logic is the same. If we have a different symbol, then there is no winner. If all the symbols are the same, we return that symbol as the winner. And the second one, the second diagonal function for the up diagonal, we just have to flip. So we have here, for instance, 0, 2. So 3 minus 1 is 2. So that's the top right cell. And then we have to go across that diagonal using this. So for instance, if we have the first row is 1, so we have 3 minus 1 minus 1, and it's going to be 1, 1. And then when you have row 2, you have 2 here, and you have 3 minus 1 minus 2, which is 0 here. So you have 0, 2, 1, 1, and 2, 0. You check all 3 spaces of that diagonal, once again, whether there is a symbol there or not. If they're not similar, we return none. If they're all the same, we return that symbol as the winner. And here we return the winner. And it's important to understand that at this point in the function, this winner could be none if all of these conditions were false. If we checked the horizontals, the verticals, the diagonals, and none of them gave us a winner, that means that the winner would be none. And this result returns to this variable. So this variable, we have either x or o or none, depending on whether there's a winner or not. And if there is no winner, so winner is none, we check whether we have filled up all the cells. So if the number of moves that have been made are equal to size squared. So for instance, on 3 by 3, if we made 9 moves, that means that the game is over. Winner is no one. Otherwise, if there is a winner, we would exit the loop here. And finally, we have this final function. This is a very simple function which flips the player to the other player. And here's what it looks like. It looks like this. If the symbol is X, you return O. Otherwise meaning that it's O, you return X. And the next player is going to be the other player. And this repeats until either we get a winner here, X or O, or the game is a tie and we get a winner here, which is no one. At this point, this loop terminates and we get to this stage. We print the final board. The reason why we print the final board, because you have to show the final result, because we print at the beginning before the move is made. We need to sort of show the final state of the board. And then we say either X1, O1, or no one won. So one of three results. And I think this is it. So let me know if you have any questions up to this point. I know this took some time, but like I said, it's like tic-tac-toe is supposed to be simple, but it's not as simple as you think it would be. So let me know if it's clear or if there are any questions you need to get clarity on. Thank you for your praise, Vicky. Masterful.
Alex, I would have to kind of reread it and go through it and try to really understand it.
Sure.
It's a lot.
I know. If you this is the first time you're seeing this, then
Yes.
Then I understand. So once again, Jay, are you in the forum?
I haven't been there in a while. I need to go
But
back there.
But I mean, if you are, and if you try going through this and you have any questions, just drop me a note and say like, Alex, I'm still confused about this and that. Help me out, and I'll explain it to you.
Okay, thank
All
you
right.
very much.
No problem. Okay, so if there are still any questions that you have, let me know. But I'd say let's move on, to the interesting stuff, the sandcastle problem. Could you possibly have us get those slides? But Blossom, those slides are in the. Oh, okay, you're not in the email list. So yeah, they're in the forum, but you're in the forum. I remember you are in the forum. So if you go to this one, Life After Code in Place session 3, you would actually have all the links here.
Okay. I thought I saw it, but I just wanted to confirm.
Yeah, they're there. Just look for messages from Vicky.
I see, yeah, okay.
Did you find it?
Okay, oh, yes.
Okay,
I
nice.
didn't realize, oh yeah, that's it right there. Okay.
Good stuff.
Thank
So,
you.
let's take a look at the scary looking sandcastle problem. Let me open it up. And I'll open, I think I already have downloaded the starter code, so let me just open the handout. And let me know, do you see my screen now, or do I have to reshare it?
I see it.
Okay, good. So sandcastles, there are several assignments in Sandcastle, but the first one is you have to combine two lists, and I think that one is not that difficult. I don't see a reason to dwell on it unless someone tells me right now by voice or in the chat, like, Alex, I do not understand how to do the first one. Please, let's look at it, and then we'll spend like 2 minutes looking at it. But the most interesting, obviously, is the third one, which is this one. Because we will actually right now write this program, which actually allows you to drop sand into a world that you create yourself, and then watch those grains of sand drop down. I know Vicky enjoyed it. I know she had like quite a lot of
nearly
excitement.
had a nervous breakdown doing that.
But
In a
you
very
were excited when you got it done.
Yes, literally like 20 minutes before section.
Right, so you had the wee moment.
I know. I mean, I feel like that's why people get addicted to like programming, because it's like finishing a marathon or something. So can I ask you a quick question about that very first one about the zip list?
Sure.
Because I think there are two ways to do it, and I actually did not know the first way, because my best friend GPT actually told me the first way. So I think that there's actually a command called zip that creates like a tuple. Okay. And then it's like literally a one-line command that does this assignment. But I don't think that's how we're supposed to do it, right?
Yeah, the idea was that you would actually write that specific function. So there is a built-in function which is called zip.
Okay.
But the idea here is, imagine that you don't have that function and you have to write your own implementation of that function. Because otherwise there is no fun in doing this. I mean, there's already a function that's done for you. So yeah, the idea was for you to create an empty list and then start adding sublists in pairs of letters or what have you. Okay, so let me.
Alex?
Yeah.
Before you start, I wonder if I could sort of preface what you do with kind of where I got stuck, which may be unique to me.
Okay.
But then ask a request of other people on this call for a reason I will say. Okay, so where I got stuck was, first of all, it was totally confusing to me initially because I had no idea about what doc tests were. Okay. And I saw these comments in the doc strings at the beginning, and then somehow I was supposed to execute these things. And it took me a while to figure out what the heck that was, okay? Then ultimately, after I fixed my PyCharm from crashing, which is a totally unique thing, and got it going, I was able to do the very first step. I wrote the code for it, and I was able to actually right-click on the doc tests, okay? And I couldn't go test by test, as they say you can in the instructions, but PyCharm did all 4 of the tests. And it gave me all sorts of green marks. Everything was looking great, right? Then I started to write code for the second function, and PyCharm blew up again for reasons I cannot figure out. Anyway, I don't think you can help me with that without seeing actually what I'm looking at. But the question I had for other people is, ultimately, I want to move from PyCharm to VS Code. Now I'm kind of doing double play because your section is using PyCharm, okay? And you suggested a couple of lines to me, which I never fully understood, about how I might be able to use docstrings in VS Code, but I'm guessing for sure there are other more experienced people on this call who would know how to do it within VS Code. I mean, with VS Code, I can do a debug and set breakpoints, but I can't go function by function and do the kind of thing that doc tests do in PyCharm. So if anybody would be willing at some point before we close to kind of educate us about how to do it in VS Code, I would appreciate that.
Sorry. If someone has experience with using doc tests in VS Code, maybe I see Mina Singh just joined the Discord. Maybe that's something that's been discussed there. But if someone is willing to share this at the end, please feel free to do so.
Yeah, only at the end. Yeah.
So I will talk about doc tests right now. I'm not sure that I will answer your questions, Nate, just for reasons of specific issues that you're encountering. I'm not sure that I would encounter those issues, but let's try and see. I'm certainly going to talk about the 2 lines which I mentioned. So the idea here is that we already have some. Just give me a second. I'll open the code. And yeah, let's do it here. Just let me open the assignment itself. I need 30 seconds. Okay, and send. There we go. Oh, come on, where is my file? Show me my file. For some reason, the file does not want to show up in my PyCharm. Let me. Okay. All right. So yeah, let me share my screen. Once again. Okay, can you see my code now? I will have to double check to make sure that everything is visible. I can't, if you're showing me thumbs, I can't see you right now. So can someone give me a vocal confirmation that, yeah, we can see your screen, Alex?
You can see it, Alex.
Yeah, we can see it.
Thank you. Discord scares me. I understand. I don't like Discord as well. I have issues with Discord. I probably would need to go to a psychologist to sort them out. Anyway, the idea behind this assignment is that we have a bunch of functions that we need to write in order for this program to work. So there is a function called doMove. There's a function called checkMove. There is a function called doGravity. There is a function called doBrownian. There is a function called doWholeGrid. And we need to write all these functions in order for this program to work, because here we have something which is, already code. It says here, I like it, is not especially pretty code. But the thing that this code does, it actually opens the program window. And at the moment, if I run this code, I will get this window. But although my question is, do you see my screen right now? Do you see the opened application? Because I don't understand whether, it opens or not when I'm screen sharing. Can you see it?
No.
So you can see it right now. How would I actually do this? Let me try again. How about now?
There it is. There it is, Alex.
Okay, so let me do this once again. So if I launch the program, I get this application, and this application is created by this entirety of code that's already been written. You do not need to understand how it works. You do not need to understand what it does. It's just there to allow you to see the result. So we do not have to figure it out. The thing that this canvas does, let's call it a canvas, is that you can actually draw stuff on it. You can draw sand. This is all sand. And at the moment, as you can see, it does not react in any way because we have not written our functions. You can also draw rock. Rock is supposed to be, stay in place. You can erase stuff. You can big erase stuff if you don't like. And there are some controls here. So this is how chaotic you want the movement of your sand grains to be. And you can actually turn it on and off. You can turn on and off Brownian motion, and you can turn on and off gravity once it works, because at the moment it does not work. We have not defined any of the functions. So this is the basic layout of the application we'll be working with once we're done writing the functions. Hold on. I hope that you're not feeling snarky. That's a great new word for my vocabulary, thanks to you. Oh, that's a favorite of ours. I'm never snarky. Alex just thinks I'm snarky, but I had to educate him on a better, more accurate word, sass. So yeah, we grudgingly agreed on that Vicky is sassy and she's not snarky, because given the fact that I'm not paying her anything to be my overqualified assistant, I would rather have her sassy and happy than snarky and not happy. So we agreed on sass. Anyway.
I'm going to launch a poll. You just keep on talking, okay, Alex?
Oh, you you sassy assistant. So, let's take a look at the first function. The idea is that for each of the functions, we have a
Alex,
yeah.
So where did you get the white window just now? So the sand.
If you run this program, so I opened the program, the file send.py, which came from the assignment, and
okay.
If you run this program, you get the window.
Oh, okay.
If you stop the program, the window disappears. Yeah. So the window appears because someone has already written the code which is responsible for the graphic application part, and we don't need to do anything with that. And this is very similar to how programming is done in production. So you would actually have a team of many people, and each person is responsible for their part. So say we're working on this program and there is a person who is responsible for the graphics part, and you have nothing to do with that. You know that, at the end of the week, the guy has to deliver, and you would have a program, and you are responsible for the logic. So he's sort of doing the front end, what's called front end, and we're doing the back end. And then we will put those two together, and hallelujah, if everything is working, we'll have an entire functional program.
Okay.
So yeah, let's take a look at the back end, the stuff that we need to do. For each function, we have what is called in Python a docstring. So this is a docstring, the doc like this, like document string. This is short for document string and not docstring instead in the sense of not that doc. The way you do a docstring is you use a multi-line comment, which is done by having 3 quotes. They can be both double quotes or single quotes. And then everything that's written after them is considered to be a multi-line string, which can also be used as a comment. And this is considered to be a comment or a multi-line string until it encounters the second pair of closing triple double quotes or triple single quotes, depending on your preference. And here we are given a description of what we need to do. So this is the description of what the function does. But this is not a complete description. To get a complete description, you would actually need to go to the handout here and read what needs to be done. So it's written in a more detail here. Like for instance, here we have a very long discussion of how do-move should work, although it's a very simple function. Besides the description of what the function should do, here you have something which is called doc tests. So doc tests is why it's called doc tests, because it's like tests which are put inside doc strings. So Python recognizes that if you have a doc string and inside a doc string you have a certain syntax, Python recognizes that this is a doc test. So for instance, here you would have like these 3 greater than signs, then like a space, and then you would write a bunch of Python commands. So it looks at this like you're entering these commands in a Python console, and then without these symbols, you're typing the response that your program is supposed to give. And then you can actually check whether the way your function is written, whether it actually succeeds in running those tests. So this is written by the programmer. The programmer says, I know that my function is supposed to do this when it's written correctly. And I know that my function is supposed to do this when it's written correctly. And so the idea is that you write as many tests as possible for different scenarios, different cases, including what's called edge cases, when you have, you're walking the rope, for instance. Often when you have, for instance, zeros as parameters, you often get some weird results and you need to check them. Or you have incorrect values, or you have, I don't know, negative values. How would your function perform? You as a programmer have to decide on how your function should work, then write the tests. And then if you run the tests, Python will tell you, all tests succeeded, your function is in line with the tests that you've written, or there are failures. And then it will give you, your function was supposed to, I don't know, return this, but in reality, it returns that, and they do not match. So you need to fix your function so that the real return value and the supposed return value are the same. So this is the thought behind using tests in general, and in our case, doc tests in particular. And after we do this function, I will show you how we can actually check whether the function works correctly or not. But first we need to write this function. So let's read the task itself. So we're told that we have a function which is called doMove, which gets a grid, and it gets two coordinates, x1, y1, and x2, y2. So we need to move the value which is located at these indices in the grid to these indices, and then return the resulting grid. This is important for testing purposes. We should assume that this is a legal move. So we know that these coordinates are in bounds. We do not need to check whether they're in bounds or not. And we can also be certain that the second coordinate is empty. So we're not trying to place something over something else. Because it says here there will be another function which we'll write later, which does this. So this is actually very simple. We get a 2D list, and we need to take the value which is at these indices and put it into the spot, the element which is at these indices. And we know that initially there is nothing here. And then we can actually take a look at the examples. So for instance, we have 3 elements in the first row, we have 0 elements in the second row. And then we say, how about we move something from 1, 0, so x1, y0. What is x1, y0? This is y0. This is x1 inside y0. And we need to move it to 1, 1. So 1, 1 this is y1. This is x1 inside 1. So we need to move this s here. And if we run the function, you will see that the s disappears from this spot and it appears in this spot. So basically the function is telling you what should be the end result of your function running. And I would actually ask for help from you. If someone cares to tell me how we could change the value in these two locations, these two coordinates in a given 2D list, give me a shout.
Yeah, so that's the very first function, right?
Yeah.
Yeah, that's actually fairly easy, I think. Because in Python, you could just literally swap them. You don't need to go through that temporary variable. And so you just need like grid y2, x2 is equal to grid y1, x1. And then you would set your grid y1, x1 equals to none, and then return the grid, and then you're done.
Okay, so what you're saying, we don't actually need to set the second one to none for the simple reason because we're moving something to a place where none is, so none would automatically be switched places with whatever's in the first coordinates. So we could say, like you proposed, we could say y1, x1, and grid y2, x2 equal to grid y2 x2 and grid y1 x1. And so it's important to note that your y's have to go first because we are used to x being first and y being second in regular math or geometry or what have you. But here, since rows go before columns, you first need to place y, and then you need to place x. And the idea is that we will take whatever is at the second coordinate and place it into the first coordinate, and whatever is at the first coordinate, we place it into the second coordinate. We could have done this through temp, like doing a temporary variable, but honestly, in Python, there is no reason to do that. But there is one more thing we need to do in this function. What's that?
You need to return it, right?
Yes. We need to return it only for the tests to work. Because if we didn't have any tests, we wouldn't actually need to return it, because any changes done to a list inside a function will persist outside the function, because it's a mutable data type. But since if the function doesn't return anything, then the doc test will not see the result, because it expects the function to return something, and it will say, I expected this on that, and I received none, so it's not the correct solution. So here we will write return grid in order to make this function functional. Sorry for the, yeah.
So, Alex, I missed something. Like, why do you need to set both grid y1, x1 and y2, x2 equals to y2, x2, y1, x1? I mean, why can't
I'm swapping them.
right, but you know, but I just did y2, x2 is equal to y1, x1. Why wouldn't that work?
And then
you need none.
From what I understand,
yeah,
then you
okay,
place
okay.
none in y1, x1. You could do it like that,
Yeah,
sure.
yeah, okay.
No problem, no problem.
yeah.
It's a working solution as well. So now let's talk about doc tests. So for instance, if I wanted to run a doc test of this specific function, what I could do is I could actually import the doc test module. And then these are the two lines that I was talking about. Like the first line is actually importing the doc test function. And ideally, of course, you don't need to do it here. You have to do it together with all the other imports. And then the line that actually runs the test, from that module, you need to run the test mod. And when you run this, it will check all the functions, I suppose all the functions which are above it. I don't think it will check the ones below, but we'll see right now. And if I run this at the moment, you will see that I do not get anything in my console, because probably my function is working correctly. But let's try doing it incorrectly. So for instance, let's put a mistake somewhere here. Let's say that here we'll just do none.
Alex, quick question for you. What just flashed on the screen, on the right of your screen, was a whole bunch of red comments. And you commented that it did this because everything was done correctly. Could you explain?
No, that appeared when I pressed the stop button. And the stop button triggers an exception which is called keyboard interrupt, and it shows you the entire traceback at which specific point in the program it was stopped. So it's not an error, it's an exception, because Python considers keyboard interrupts to be a type of an exception.
Yeah, so that was one place I got tripped up, because I
know it looks dangerous. But it's nothing to worry about. So let me do this again. So for instance, you see now I launched the program and it gives me a bunch of failures. So it says that one items had failures because for the do move function, when I do this, I expected this, but instead I got this stuff. And it says it's like, this is wrong. This is not the way it's supposed to be. And I'm going like, okay, thank you. I sort of understand.
You can specify which one you want to test.
You can specify where in the parameters.
Yeah, you can say name equals.
Oh, okay. And then do it like as a string, or do you actually pass the function itself?
As a string.
Like this? Like do move?
Yeah.
Okay, yeah. So, you know, I learn something new every day. I'm not a big user of doc tests, but yeah, thanks for pointing that out. So now, as you can see, we have failures. If you do everything correctly, you do not have failures. You do not have anything.
Before you go on, just in the documentation and in the handout, it said that you could just right-click on a specific doc test, not all of them, but just on one, without the importation of doc tests or that extra line, and you could
Yeah.
run a doc test. And in fact, I didn't, for the first function, which I got, I was able to do that. I right-clicked, but not exactly. I right-clicked on the first one. I didn't do the 2 lines that you suggested, and
Yeah.
it ran all 4 of the doc tests, not each one singly. So
Yeah.
that kind of confused me, but just pointing out that you don't have to do the import within PyCharm, because it already will do it for each function.
I tried doing it. It did not work for me. Where do I right click?
Right click on the very first grid equals, right on the very first doc test.
Like
Not
here.
there, but- yeah, right there. Yeah, right. Yeah. And then it gives you an option, okay, should give you an option to maybe go into the statement itself, but it gave me an option to just run the doc test.
Yeah, because that's the problem. I tried doing it and I couldn't find this option. And
Huh.
I'm thinking maybe it's, maybe
I
it's
think
a
it's
Mac
because
thing.
I think it's because you're importing doc test and you have the extra line. I'll
No,
bet you if you
Let,
get rid
let
of those.
me comment it out, because I initially tried it without doing this, and it still didn't work for me. Like, it's still
Why don't you skip
context.
right over past the equal sign on the first line?
Like
Yeah,
here.
right there. Yeah.
I still don't.
Wow, that's weird. It does it for me. Anyway, what a puzzle. I'm really glad somebody mentioned that you could enter the name of the specific function
Yeah.
in the parentheses for doctest.mod. And it's quite possible maybe that will work in VS Code too. I don't know. I'll have to try it.
Possibly, yeah. But I did not expect it. Like the even if it works in PyCharm for you, it's not basic Python functionality. So it's something like one of the bells and whistles that you get with PyCharm. So you sort of still have to understand how to do it if you don't have PyCharm. If you do it from a console, and you would do that by importing doc test.
I totally agree with you, and that's really good to know. The course, of course, on the handout, didn't do that, so that was just a point of confusion. So
Okay, got it.
I'm following. Yeah.
So now we have one function which we confirmed it works correctly. But if we launch the program, nothing changed. We still have send that's not falling, we have rocks, and we sort of go, okay, we wrote a function, but it doesn't do anything. What's the point? The reason for that is because we're not using this function anywhere. Because the following functions which we'll need to write will use this function and we'll actually call this function. So let's go to the second function which we have, which is called check move. And here we also get a grid. We get the starting point and we have the destination point. And we actually have to check if it's possible to move whatever's at the first coordinates to the second coordinates. So the first coordinate is always in bounds, but we need to check that the second one is also in bounds. Here, we're not guaranteed. We actually have to make sure that it's not outside our grid. And we have to either return true if the move is okay, or false otherwise. An okay move is in bounds. So it's inside the grid. It's actually empty, which means that it contains none. And it's not violating corner rule. And if you are not sure what the corner rule is, you have to look at the handout, because here it's explained what legal moves are. So obviously one of the legal moves is falling down. So if you have gravity and you move from a point to exactly a point beneath you, directly beneath you, that's one thing. But also there is diagonal movement, and diagonal movement can be done, like here as an example. You can only move diagonally to a spot if the spot directly to the right of you or to the left of you is empty. So only if this specific location is none, because here you see you can move here, but you cannot move here because this blocks your movement. This is rock, this is sand, this is rock. This rock blocks you from moving diagonally. So you would be able to move here, you would be able to move directly below, but you cannot move here. And you have to write these conditions. So back to our, and we obviously have a bunch of doc tests that we need to check. And as you can see, there are a lot more doc tests here to check various edge cases. So let's first, so the conditions that we would be checking, the first thing that we need to check is that these coordinates are actually in bounds, because if they're not, if they're out of bounds, we need to end everything immediately. So we would say if if x2 has to be somewhere between 0 and it has to be somewhere, so if it's x, let's start with y, it's a bit easier with y. So if y is between 0 inclusively and the length of the grid exclusively, that means that it's inside the grid. So for instance, let's say we have a 2x2 grid. So any y which is 0 or 1 would be inside the grid. If it's higher than 1, it's already outside. If it's lower than 0, obviously it's outside. So if this is true, and the same applies for x2, the only difference being it's not len of grid, it's len of grid 0. So we take the length of the first row. So if this is true, then we're inside the grid. So let's flip it, and let's say if this is false, now we have a poll. Yeah, I can't code and poll at the same time. Who do you think is more really? Who do you think is
It's
more
okay.
smart?
Alex, you just keep on talking, you know, like
I can't because the poll is in the center of the
It
of my
is?
screen.
I can't move it.
I can move it, but I can't get past it. So it's kind of a, I'll just,
Okay.
do I have to vote in it? Do I have to vote in it?
You can't vote. You can't vote. I can't vote, you know?
Okay, I see you already voted because you chose me as the snarky one.
No, I cannot vote. We're hosted. It's not me.
Okay. Okay, so
It's okay.
yeah, I'll just
I will end the roll.
I'll stay neutral. I will not vote in this.
Right. I didn't vote, you know, so
Okay, okay. I believe you. I believe
please
you.
continue. I'll just close it.
I just see that there are some Wiki followers in the crowd, so that's okay. So
I'm just bored, sorry.
in case our coordinates are not inside the grid, we should return false, and that's that. We're done with this condition. So now next, if we're inside the grid, we need to make other checks. So let's first check whether maybe it's a vertical drop. So we're trying to drop from some location directly to the location below. So how would we write this? If the x is the same, so we say if x1 equals x2, and y1 is sort of one higher, is one, well, it's one less than y2, and we actually have none in the coordinate where we're trying to get. So if grid y2 x2 is none, so if all of these are true, I think we could return true. So what I'm saying is it's the same column. The second y is below the first y. So the first y is the second y minus 1. So for instance, if we're moving from 4 to 5, y2 would be 5, this one would be 4, they would be equal. 4 is equals 5 minus 1, and we have none at that location. I don't know, why is it underlining this? Why are you? Oh, I think I didn't close the parentheses correctly. There we go. So this would be a correct vertical move. Now we need to check the two diagonal moves. Diplomatic answers to the poll. Sure, someone has to be diplomatic. So let's first check the first the first diagonal, which would be x1 equals x2, for instance, minus 1. So that would be a move to the down and to the left. No, down and to the right. Yeah, down and to the right. And the condition for y remains the same. We could actually write the condition for y here separately. We could say if y1 equals y2 minus 1, and then write these as subconditions, because it would be the same everywhere. And we could actually write this one as well. This one would be equal everywhere. We need to make sure this is true. Like this. And then we could do this in one big or x1 equals x2 minus 1, or x1 equals x2 plus 1. Equals here, equals here. Then return true. In all other cases, we return false. So one more time, the idea is, first we check whether we're inside the grid. If we are not inside the grid, we return false. Then if we are inside the grid, we check that we're trying to move to a location which is 1 below the current location, and that the location is actually empty. So it has to be as none here. And if both of these are true, then we need to check the x's. So the x is either directly below the current one, or to the left of the current one, or to the right of the current one. If any of these three are true, we return true. But the thing that I did not check is the corner case. That's one more thing that I need to check, the corner case. So yeah, let's then split this into 3 to make it more readable. So if this, we return true. If, and this is going to be the third if, like this. So if we want to move to the left, like x1 is x2 minus 1. So here we're moving to the right. This is, let me write like diagonal movement to the right. And this will be diagonal movement to the left. Diagonal movement to the left. And this is movement down movement. And this is, are we in the grid? So in case we want to move to the right, we need to check that whatever's located at our y and the x is -1, it's empty. And we need to do the same if we say if grid y1 and x1 plus 1 is also empty. So in both of these cases, we also return true here. We return true here. And in all other cases, we return false. What are the other cases? Other cases is we're trying to skip more than one location. and we're trying to go to a location which is not empty. In both these cases, we're not going to move anywhere. The movement is not legal. And here we have like 3 cases where it's legal. All the rest are, so like moving in diagonals, which are more than 1 space away from the initial space, is also impossible. Or we have corner cases which do not allow us to move. So these ones, the one where we have something to the left of us or to the right of us. Let's see whether this actually works, because this is all nice, but the question is, will this actually work? Can we do the doc test on it? So let's do doc test mod. And what's the name of the function? The name of the function is check move. Check move. Let's see if we get any errors or not. Oh, yeah.
So the square bracket, so the right, so the closed square bracket, the location is behind none. Is it?
Oh, here, this one. And I think I have somewhere here. I also,
yeah, that we need to put it
okay,
there
and
as well.
I need to put it. Yeah, thanks. Let's do this one more time. And I still have some cases where I'm wrong. So I have like 3 out of 10 tests have failures. So let's see the specific ones. So grid 1 0 to 0 0. Yeah, unfortunately I don't see the grid itself. So let's try and understand which one this is, like 56. So I have this grid and I need to move from 1 0, which is this, to 1 0 to 0 0. Oh, it's trying to move. Is trying to move up. Just give me a second. Okay, Y1, no, this one, from 1 0 to 0 0. How would it actually move upwards? Am I crazy here, or is this actually trying to move upwards? Either that, or it's past 1 a.m, so I'm sort of groggy. So these are the initial coordinates. These are the coordinates where we're trying to get. And, oh, sorry, this is the X. This is an X, so we're actually trying to move to the left or to the right. Okay, so this is true, because in some cases with Brownian motion we are able to move to the left or to the right. Okay, I forgot about that. So we also need to check the option where we're actually moving horizontally and not vertically. So Vicky, let me check with you. So this means that we have like half an hour tops, right?
No, you have 40 minutes. Sorry. Well, hopefully in 40 minutes you can finish this, because otherwise we'd be going on 4 hours.
Right.
I don't think you want to.
Right. Let's try doing this in 30 minutes. Okay, so what we need to do is we actually need to check the sideways movement, whether it's possible or not. And in this condition, the condition is that the y is the same. So we're saying if y1 equals y2, and here we would check. So if x, for instance, if x1 equals x2 minus 1, and it's like, is it the same? Oh, it would be the same condition. Okay, so then we don't need to, we could do this. We could just cut it from here. And we could place it, I think we could place it here, like, or this. So we're saying if we're going down or we're moving horizontally and the place we're trying to move is empty, the only error we could get, like if the function tries to make us stay in the same place, because here like the y is the same, the x is the same, would that be considered a legal movement? I guess it would. It means staying in place, so I don't think that's illegal. And here, I don't think this would bother us, because in case of horizontal movement, this would be the same as this, so we can twice check whether it's none. But let's check. Let's see whether the tests will work now. No, we still have false ones, and they're still not working. Let me try to understand where I'm doing this wrong. So if we're going down, or if we're staying at the same place, and
Alex, basically, are you missing a condition where if the grid is not none, then return false?
I think I have it like here, because if the grid is none, this is
Okay.
one, it has to be none in order for all of this to work. And if it's not none, it drops to this false.
Okay.
So I don't think it's a question of that. I think given the error messages, it's for some reason doesn't allow it does not move sideways. And
because whatever I wrote, it passed all the doc test.
sure, whatever I wrote when I wrote this first time also passed all the doc tests. So
You should probably
I-
just save your code.
it
I
is
think it's
actually
because
saved,
of the
but I
way
mean
you've written.
it's not very helpful if I just show pre-written code. Sorry, I didn't hear you.
It's because of the way you've written the diagonal test, I think. And you
You think?
also don't need to have the horizontal test like that. Like all you'd need to do is check that where it's going is an empty like square, so it can go. So basically, it's the y2x2. Like grid y2x2 is not none, then
Yeah, but
you return
this is,
false without
this
having
is,
to check for the.
but this is not enough, because you can only go to the adjacent space. You can't jump from 0 to 10. I don't think you can. I mean, I think this one checks whether you're actually going to an adjacent location.
Yeah, but then the way you're going to write the rest of the program anyway, you're never doing like a 10 square jump or anything like that. They're going to be going like 1 square.
Okay, so you're saying that this condition is unnecessary.
Yeah. So
Because
you would only have check the grid y2x2, which is where you want to go.
okay, let's give this.
So obviously you have your first condition to check that where you want to go is inside the whole thing.
Yeah, but
So,
this it
right,
seems
which
that
is fine.
is working. Yeah.
Yeah, that's fine. And then the next one, all you need is to check that the condition where you're going is empty, or if it's not, then return false, right?
Okay, yeah, that's what it does here. But still, it gives me the same three errors, so it's not necessarily here. So
No, because
just
you would have that separately as just a single if condition, and then the third is where you look for you have the diagonals. Well, that's how I did it anyway.
But I'm trying to understand where do you think the error is? Because it's not here. I just removed it and it's still the same error. So
No, because what you have is you have an if that's checking whatever, and then you have these which I think you've written it. It's a bit weird. The diagonals. So you just have a separate if for the check where you're going, without having nested ifs within for the diagonals and that.
I mean, I could have written this in one long if, obviously. The reason I split it to make it more readable, but once again, you're not, do you have an understanding of where the error is?
Alex, could it be that the error is that you're using a bunch of if statements rather than elif statements? Because if you use if statements, right, there's the chance that more than one if could be.
No, because you have returns here.
Oh,
The
right.
return sort of goes out of the function, so it will not get to the next if unless it's false. So that's not the issue. I'm just trying to. So if x is equals here, why isn't it working horizontal? It's not. The problem is that the tests which are failing are not about. Well, at least this one is not about diagonal movement. This one, I think, is like corner rule, and this one is. So down left, okay, it should be true. For some reason it's false, and here it's the other way around. It should be false, but it's true.
So when you're doing the diagonal movement, you're not actually moving down diagonally?
So I'm like here, I'm looking at the x, so I know that I'm either going down or staying on the same line. And let's say I'm going down diagonally to the right, and I'm checking whether whatever. Oh, hold on.
There should be y2 if you're going y1 plus 1.
Okay, this is the mistake. I had 1 and I'm supposed to have 2, so that's where probably the problem is. No, still no. No, still the same thing. Y2 and x2 minus 1, x2 plus 1. Boom. Yeah, I'm just like at the moment. I have like monkeys going in my brain, like ching, 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 ching. So I only have 2 now. So I had 3, so we fixed at least one of them, which is the down left, which was okay. So we fixed the unblocked rule. So why doesn't it work? Why doesn't it return false? Here it's supposed to be false, but it returns true. Okay, so let's check. We're moving from, like, which one is this? Like 68. It's the last one.
Alex, so for
Yeah.
your last 2 diagonal condition, what if you were to change it to like x2 is equal to x1 plus 1?
X2, you mean this one?
Yeah.
But it would be the same as this one then.
Yeah.
So why would I do that?
Because that's what I wrote and then it worked.
I think she wanted to rewrite the first and the second both as x2 equals x1 minus 1 and x1
Yeah.
plus 1.
Correct. Yes.
So like this and like this and change them here to this and this?
Yeah. No, I mean, wait a second. Yes, try that.
So this is movement to the right, this is movement to the left. This is, but then I don't think that this is movement to the, so
Then you get rid of -1 and +1 there, so you just takes 2.
here. So if this is moving to the right, then I need to check the right one and I need to check the left one. I think I don't even know, it starts doing weird stuff. It goes somewhere, there is an index out of bounds, so no, hold on.
Are you checking the corner conditions?
Sure, these are the corner conditions, this one and this
Oh,
one.
those are the corner
So
conditions.
like this, no, hold on. We changed it to 2, but it's not supposed to be 2. It's supposed to be y1 here and y1 here, but actually maybe this is the issue. Ah, just kill me.
Hey, Alex, do the if statements at the beginning need parentheses?
Which one? Which line number?
The sublines, if x1 equals x2, and then
This one.
yeah,
Yeah, you don't need parentheses here.
no,
Python does not require parentheses for if statements.
okay.
Okay, one more time. So if the new x is the old x plus 1, we're moving to the right and we're diagonally, right? We're moving diagonally or horizontally. In both cases, the one we're moving to has the same y. So the y, oh, hold on. But now we're checking it here. So the y is the old one and the x. Oh, hold on. Maybe it's this. Okay, there we go. Stupidity overcome. We're past this one. So basically, if I'm using x2, like this is the x where I'm going, so it's useless to add something or subtract something from it. I think we initially had x1, we had something like this. I wrote something like this, and probably this is the place where it was incorrect. And then we just changed it to x. Yeah, it works like this as well. I guess I had them mixed up. Maybe I had the pluses and the minuses mixed up, and now we changed it back, and so it seems to be working. So yeah, a bit of a spat we had here with this function, but we figured it out.
Alex, I have a very quick question.
Shoot.
At the beginning of that function, for the very first doc test, could you go up to the very first doc test?
Yeah, this one.
Yeah, I didn't understand conceptually, and it threw me off. Why making a grid that's a two-dimensional grid with a single element checks for the boundary conditions? I didn't follow that.
Well, I mean, this is a 1-by-1 grid.
Right.
So the left is blocked in the sense that you would go out of bounds if you tried to move anywhere.
But how does that do what you did when you checked for the width and height of the grid to make sure it wasn't there? I don't understand the function of that. Conceptually, I got lost there.
You mean you don't understand the test itself?
Yeah. Why
Okay.
why does it do anything that obviously you got it right now, right? But
I
can't.
think I understand your question because it basically says move from coordinate 0, 0 to coordinate -1, 0. And -1 is really,
I don't know what that means in that context.
I mean, I think the check here is to see whether you would let a negative index pass, because negative indexes do exist, because a negative index means sort of like the last line. And I think this test is just making sure that you are using this condition, that you're not allowing negative indices to go past.
You're probably right. I just had trouble following that.
I think that's the logic, because theoretically you could have used negative indices to say, for instance, in a 2x2 matrix, you could say, check whether I can go from the 0th index to the -1st index. And that would be a possible move, because a -1st is, in that specific situation, the first index. So you could go from the 0 to -1. But I think this function wants to check that actually all of your indices are positive. And this would generate an error.
What you did makes a lot more sense to me. And I just got really confused by that.
It's my guess. I cannot actually guess what the idea behind it was, because I did not write the specific test, obviously. But I think that's the reason, because that's the only test in the entire function which has negative values. So I think they're checking for that error condition.
Thanks.
Okay, so now we have two functions. We have the first function which actually does the move, and we have a second function which checks whether a move is possible. So, and as you can guess, we would then need to combine these two functions for movement. For each possible movement, we would first check whether it's possible, and if it is, we would do it. So for instance, here we have the third function which we'd want to write is called doGravity. And the idea behind doGravity is that we have a grid. We have the location inbound location of a of like sand. And we need to check if there is sand at that location, then we will try to make one move in the following order. First, we'll try to move down. Then, if it's not possible, we'll try to move down left. And then, if it's not possible, we will try to move down right and return the grid in all cases, whether, you know, we did this move, or we did this move, or we did this move, or we did none of these three moves. So what we're going to do is do the following. First, we're going to check if we can go down, and we already have a function for that. So we're going to say if check move, we have the same grid, x and y that we're given at the moment are the location of the sand there. So we will check the move for x and y here. And when we're checking the move down, we are going to check x and y -1. And I'm not sure, the only thing I'm checking if I suppose we need to check if we have sand there. Vicky, you're saying something?
Sorry, if you're checking down, would that be y +1 or y -1?
Yeah, thank you. Sorry, yeah, I'm already getting a bit woozy. It's obviously +1 because we're moving.
Yeah.
The axis is moving, towards the bottom. Thank you. So the first thing we need to check is we actually need to check whether it's sand, because if it's not sand, I think we are not.
You're done. And so to check sand, you would just write if grid yx doesn't have that s in it, and then it would return grid.
So if it's S, we would do all of this. Otherwise, we would return the grid. We would return it in any way, yeah, unchanged. So if this move is legal, we would do that move. We already have the do move function for that, for grid x, y, x, y plus 1. So here we're checking the vertical movement. Otherwise, and here we would need to do the elif, because we will only do one of those three moves, or none at all. So if the first one fails, then we check the movement to the, which one was it? Was it the
You could do down right or
right.
down left. It's
First,
dealer's
down left.
choice. Oh,
It's not dealer's choice. You have to do it in this specific.
oh, okay,
in
all
this
right,
specific. So
Okay.
first this one, then this one, then this one. At least according to the algorithm.
okay, that's fine.
So in the second one, we try to see whether we can go from xy to x minus 1, y plus 1. Does that sound correct?
Correct.
I think this is down left. And let's do a copy like this. And then the third one that we are checking is whether we can move down and to the right. So that would be x plus 1, y plus 1, and here also x plus 1, y plus 1. And then in all cases, we return the grid regardless of whether it was changed or not. So let's try testing this one as well. And it's called, what's it called now? It's called do gravity. Okay, do gravity.
So, Alex, that command doctest.testmod, it replaces just clicking on the entire doctest code, right?
Clicking on the entire doc test code does not work for me. So it does not replace this for me. It's the only way I can do it.
Okay.
So it seems for me that for some reason on Macs, the right clicking actually works, but on my PC it does not work.
Okay.
I do not know why. Maybe there is a difference between the Mac version and the PC version for whatever reason, but we did not get any errors right now for this one, so this one seems to be working perfectly. So the next one we're tasked with doing is do the Brownian movement, and the way the Brownian movement is you are given the grid, you are given the coordinates, and you are given the percentage for how likely it is for the movement to actually happen. And if I remember correctly, the Brownian movement is always to the left or to the right. You first check whether it can be done to the left, and then you check it. Or no, I think it's the other way around. You first check whether there is movement, and if there is, you randomly pick either left or right, and then if that movement is possible, you do it. I think that's the way it was written in the. I think that's the way it was written in the.
Well, you first have to check if the grid has sand in it. Okay, if there is no sand, then you don't do any Brownian movement.
Okay, so you have to make sure that there is sand there, right?
Correct. Because
Okay,
obviously you
that's-
can't do Brownian if it's empty, or if it's a rock.
Okay, so let's do this one, but it's like yx only,
No.
yx.
And then you have to generate a random number.
Sure.
Between like 0
From
to
one,
like
like
100.
chance equals random rand int from. Is it from 0 to 100 or from 1? So if
Well,
I
it was
can-
actually 0 to 99.
but it should be, so for instance, if you have Brownian set to 0, that means that whatever your number is, there should be no movement.
Correct.
So it should start from 1. And if your Brownian is 100, it means that let's say if your Brownian is 99, that means that there is 1% chance that it's not going to be happen at 100. So it should be from 1 to 100, I think. And then you would go if that chance is more than your Brownian. In that case, you would do the movement. And do we select randomly the direction, whether it's left or right?
Oh, I don't remember. Let me see. Oh yeah, there's a coin flip to actually
Okay.
decide the direction. And so there's a random toss between like I think
Left
0
or right?
1.
Okay, so I'll do direction
that
between
number.
-1 and 1. And then I would say, I would check whether that movement is possible. So I would say if check move for grid from XY to X plus direction Y, then do that move. Does that look logical? And I don't remember whether we need to return anything, but probably we need to return the grid.
Well, what's your Oh yeah, okay, yeah. Since you said direction to ±1, I think that's fine. Hold on, what did I write? Okay. You do need to return the grid at the
I
end.
did, yeah, because we need it for test.
Yes, I think that looks fine.
Brownian motion goes in all directions. Yeah, Nate, I'm aware, but in this case, it just gives an additional reason for grains of sand to move left or right, so they don't just, stop like blocks. But yeah, I mean, usually Brownian motion is in liquids or in gases, I suppose, not in solids like sand. Let's check whether, yeah, it doesn't give us any. I wonder if anything. Yeah, of course, there is nothing happening for the simple reason that we have not written the final function. So we should actually do the whole grid. This is the last function that we need to write for everything to come together and actually start working. So the idea for the final function is that we're given a grid, we're given the Brownian integer, and we need to do one round of gravity and Brownian motion over the whole grid. So the idea is that we need to go across all of the sand grains that we have, and we're going to do that in a double loop. So we will have for y in range, and here the range is important because we need to go from bottom to top. So we need first to have the bottom sand fall, then the next one, the next one, the next one, because if we do it the other way around, nothing will fall in except for the bottommost sand grains. So we will start from there is no sense in checking the final index because there is nowhere to fall, obviously, from the final row. So we will start from len grid. Is it -2? Would that be -2? So for instance, if I have a grid of 5, I would start from 3.
Well, they told you to use a command called reverse range. And so the reverse range just starts from, I think, whatever number your grid is reverse.
But I am doing the reverse here.
Oh yeah. Well, okay. The way that they suggest you write in the instruction is for y in reversed.
Okay, they're
parentheses.
using the reversed. Okay, they're
Yeah.
using the reversed function.
Okay, that way you don't need to type all those other parameters. You just type like rows.
Yeah, I'll stick to this. This is. And here I go from 0 to here. I just go len
Always,
grid
yeah.
0, whatever. And now I check if whatever's at that coordinate is send. Then I would
You would first do gravity, right? And
first
then
do gravity and then do Brownian.
do Brownian. And then
Okay.
you're done.
So we do gravity grid at XY. And then I would do Brownian at grid XY. And is
Well,
that it?
wait, no, because the Brownian has an additional parameter that's Brownian,
Which is Brownian, yeah. I need to do this.
and then
And
return the
I need to
grid.
return the grid as
Then you're
usual
done.
to make sure that everything is working. Let's do the doc test first. What's it called? Do
I was
hold
gonna
grid.
wait to find out later, but it's just a little tiny silly question.
Sure.
Brownian is an actual term. It's lovely to see, a little bit of science in there. So I was wondering, is that parameter like a preset name in either Python for a particular, is it a preset parameter? Is this, because you said parameter, so I'm thinking it's not something that we have to define as a variable. It's something that's pre-existing. I mean,
Are you,
I haven't.
do you mean in specifically the number, like the parameter which is called Brownian?
Yeah, just a general overview. Like I've been
Okay.
kind of ill, so I'm so behind on the assignments. So I'm just trying to get like a general overview of how to do this. So I have a lot of gaps, watching, but I know I can fill the gaps later when I read. I was just very curious, like I was the term Brownian, when
Sure.
Vicky said that that's a parameter that's required for that particular function, I believe, that you're defining.
Right.
I thought I should ask because I was trying to Google it.
No,
And,
what I meant is that function do Brownian, okay,
mhm.
has a parameter Brownian that will tell the program like how quickly the sand particles would move. Okay, that's not a physical term. That's just something that particular function wanted. And basically, my understanding is that Brownian term is something you can set on the canvas to kind of determines how quickly you want those sand to like vibrate.
Yeah, so
Yeah.
here in the application, you have the slider, which controls the amount of Brownian movement. So if you set it to 0, there will be no Brownian movement. If you set it to 100, every sand will vibrate every round, go either left or right if possible. So initially it's set to 20. So this has nothing to do with Python. It's just the name of the variable, and we're simulating, in a certain sense, the Brownian movement that you have in physics, in gases,
Yeah.
or in
Yeah.
liquids. But it's not tied to Python specifically.
Oh yeah, I was just amazed. I thought, oh, that's cool to have, Brownian movement, and somehow they kind of coded into some. I was wondering if Python had, that parameter.
Oh yeah,
preset. I thought that was cool. But
if
sorry to
you look
interrupt.
right now at the program, at the canvas, you will see that actually the sand pieces are dancing back and forth, which is the
Nice.
Brownian movement. If we turn it off, they, for some reason, still continue doing it. I don't know why.
Well,
This is-
because
I get it.
because like basically I think you start running
Because you want to make
program,
it less.
the program will always think it's supposed to do Brownian until you like quit the program and then restart it.
Oh, I see. That's
I'm
cool.
not
That's really, really
sure.
cool.
I'm not sure.
And you need to have less for Brownian, not more.
Sorry, I didn't mean to put everyone behind, but that really piqued my interest.
Sure. No, it's a good question, and I'm not sure why it's continuing to do this, even when
That's
even
weird.
when
You want
it's
chance
turned.
less than Brownian instead of more in your code.
Oh, that could be the case. So let me check. If chance is more than
Oh,
Brownian,
yes.
it probably, okay, there we go. It
Yes,
should be
yes.
less.
Thank
Okay,
you.
thank you. Thank you. Okay, so now we have slow Brownian. Now we have no Brownian. Now we have a lot of Brownian. Yeah, that was the problem. That was the
That
problem.
is so
because
cool.
yes, so you see, Blossom, it's a good thing that you asked the question. We figured out why it behaves so weirdly. There we go. So,
Thank
and
you.
we basically, we have the entire program, so let me do something fun with it. So I can, for instance, the one that I like is to actually draw something resembling a hourglass. And I will pour sand in the top part, and we will actually be, it's an ugly hourglass, I'm sorry. But you get what you get. And I will pour the sand in the top part, and we will be able to see how it goes to the bottom. And I'll make the opening very small so it's not as fast, something like this. And now, ladies and gentlemen, let's pour in the sand. Yeah, I made some holes. La 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 la. At least I get to have some fun when I'm done with the code. Let me put some rock back here.
Awesome, I love it.
So yeah, I had some holes, some part of the sand is sort of in here, but as you can see, the main part stays inside. Yeah, and it does what it's supposed to do. It simulates the falling of the sand, and you actually see we get this mountain of sand here. So yeah, I think we're there, and I know Vicky has like only 3 more minutes remaining before she needs to go on the next conf call.
I'm so sorry. I don't mean to rush you. This is actually very cool, but I also
we need to wrap this. We need to wrap this up. I know it's work is important. So everyone, thank you very much. I mean, when I'm saying that I could not have done this without you, this is the truth, because some of the comments that you helped me with actually helped me finish this. Next week, I will probably not be with you, and if I will be as one of the students and not the teacher, because you will have another speaker. So if I do see you in a week, we'll see you in a week. If not, then in 2 weeks, like Vicky said, we will discuss the topic of files. And I think that's that. We have 50-50 in snarkiness. So, we're tight. Teamwork, good stuff. Vicky is sassy. Vicky is not snarky. So, okay, from now on, I mean, the people have spoken. You are sassy.
and no one wants to be your assistant.
Yeah, I'm not surprised at that.
Yeah. And you actually won the bet today, because I don't think we had 30 people.
I did. And I can't say that I'm, particularly excited about it. I think you get more of a kick out of it than I do, but I'm happy to indulge you in your gambling problems.
Yes, it's okay, so thank you for humoring me. So I've gotta go, everyone. So Alex, please send me the code.
We all have to go. Yeah, so I'm shutting everything down.
Well, you know why this meeting is important for me, so.
Right. Okay, everyone, once again, if you have any questions, please write them in the forum. I'll happily answer them. And bye-bye. See you next time.